Download this code from codegive.com, link in the description below. OK, let's dive into etc. You suck at programming 027, and try to unpack what the author is likely getting at and how you can use the core concepts to improve your programming skills. This You Suck at Programming series, while abrasive in title, aims to highlight common pitfalls in how programmers approach problems and to suggest more effective, structured methods. Disclaimer **: I don't know the exact content of You Suck at Programming 027 without directly accessing it. But I can infer from the general thrust of the series and common programming weaknesses what it might cover. I'll aim to provide a tutorial that addresses likely problem areas. My assumption will be that the topic revolves around complexity management and abstraction, likely within the context of object-oriented programming, OOP, or design patterns. I'll also include a bit on testing to ensure maintainability. Core idea **: the likely message is that many programmers create overly complex, tightly coupled, and difficult to maintain code. They often fail to use appropriate abstraction techniques to hide complexity and create reusable components. This lack of abstraction makes code harder to understand, harder to debug, and more prone to errors when changes are required. Outline ** 1. The problem: code smells and spaghetti code. 2. Abstraction: what it is and why it matters. 3. Principles of good abstraction: solid principles, focus on single responsibility, open/closed, and Liskov substitution. 4. Techniques: common abstraction methods. **functions/methods. **classes and objects, OOP. **interfaces and abstract classes. **design patterns, strategy, factory, template method. 5. Example: refactoring a complex function. 6. Testing, ensuring your abstractions work. 7. Pitfalls to avoid. 8. Practice and iteration. 1. The problem: code smells and spaghetti code. Code smells are indicators of deeper problems in your code. They're not necessarily bugs, but they suggest that your code could be improved. Spaghetti code is a common term for code that's tangled, unstructured, and hard to follow. Here are some common code smells related to poor abstraction. *long methods/functions. Methods that are hundreds of lines long often do too much and are difficult to understand. *large classes. Classes with too many responsibilities violate the single responsibility principle, more on this later. Duplicate code. Repeated code snippets are a sign that you're not abstracting common logic into reusable functions or classes. Primitive obsession. Using primitive data types, example strings, integers, excessively instead of creating meaningful classes to represent domain concepts. For example, using a string to represent an email address instead of creating an email address class. Switch statements /if-else chains. Long chains of conditional statements often indicate that you're not using polymorphism or other techniques to handle different cases effectively. Tight coupling. When classes are heavily dependent on each other, changes in one class can ripple through the entire system. Global state. Relying heavily on global variables makes it hard to reason about the state of your program and can lead to unexpected side effects. 2. Abstraction: what it is and why it matters. Abstraction is the process of hiding complex implementation details and exposing only the essential information to the user. It's about creating a simplified view of something. Think of a car. You don't need to know how the engine works internally to drive it. You interact with the steering wheel, pedals, and gear shift, a simplified interface that abstracts away the engine's complexity. Why abstraction matters. Asterisk reduces complexity. Asterisk makes code easier to understand and reason about. Asterisk promotes reusability. Asterisk allows you to create components that can be used in multiple parts of your application or in different applications. Asterisk improves maintainability. Asterisk makes it easier to modify or extend code without breaking existing functionality. Asterisk encapsulation. Asterisk protects internal data and logic from external modification, preventing unintended side effects. 3. Principles of good abstraction, solid principles. The solid principles are a set of guidelines for object-oriented design that promote good abstraction and maintainability. While all are important, these three are particularly relevant to abstraction. Asterisk single responsibility principle, SRP. A class should have only one reason to change. In other words, a class should have only one job. If a class is responsible for multiple things, it becomes more complex and harder to maintain. Asterisk open/closed principle, OCP. Software entities, classes, modules, functions, etc., should be open for extension but closed for modification. This means you should be able to add new functionality without changing the existing code. This is often achieved through inheritance or composition. Asterisk Liskov substitution principle, LSP. Subtypes should be substitutable for their base types without altering the correctness of the program. This means that if you have a class A and a class B that inherits from A, you should be able to use an instance of B wherever an instance of A is expected, without causing unexpected behavior. 4. Techniques, common abstraction methods. Asterisk functions/methods. Asterisk the most basic form of abstraction. Break down large tasks into smaller, well-defined functions. Give functions meaningful names that describe what they do. Asterisk classes and objects. OOP. Classes are blueprints for creating objects. They encapsulate data, attributes, and behavior, methods, into a single unit. Asterisk interfaces and abstract classes. Asterisk interfaces define a contract that classes must adhere to. Abstract classes can have some implemented methods and some abstract methods, methods without implementation, that subclasses must implement. Asterisk design patterns. Asterisk reusable solutions to common software design problems. Some patterns are particularly useful for abstraction. Asterisk strategy pattern. Asterisk allows you to define a family of algorithms and encapsulate each one into a separate class. This lets you swap algorithms at runtime. Good for handling different tax calculation methods, payment processing methods, etc. Asterisk factory pattern. Asterisk provides a way to create objects without specifying their concrete classes. This decouples the client code from the object creation process. Good for creating different types of data access objects, logging objects, etc. Asterisk template method pattern. Asterisk defines the skeleton of an algorithm in a base class, allowing subclasses to implement specific steps without changing the overall structure of the algorithm. Good for processing data in a standardized way, but with variations in the individual steps. Example, refactoring a complex function. Let's say you have a function that calculates the price of an order, taking into account discounts, shipping costs, and taxes. It might look like this. This function is too long, does too much, and is hard to maintain. Let's refactor it using abstraction. Changes asterisk. Asterisk SRP asterisk. We've split the original function into smaller classes, each with a single responsibility, calculating discounts, calculating shipping costs, and calculating taxes. Asterisk reusability asterisk. The discount calculator, shipping calculator, and tax calculator classes can be reused in other parts of the application. Asterisk maintainability asterisk if we need to change how discounts are calculated, we only need to modify the discount calculator class. Asterisk readability asterisk the calculate underscore order underscore price function is now much shorter and easier to understand. 6. Testing, ensuring your abstractions work. Testing is crucial to ensure that your abstractions are working correctly and that your code is maintainable. Write unit tests for each of your classes and functions, focusing on testing the public interface, the methods that are exposed to the outside world. Here's an example of how to test the discount calculator class using Python's Unitest framework. Key testing points asterisk. Asterisk arrange, act, assert asterisk a common pattern in unit testing. Arrange the test, set up the data, act, call the method, and assert, verify the result. Asterisk test boundary conditions asterisk test cases with edge cases, example 0 values, negative values, empty lists. Asterisk test different scenarios asterisk test different inputs to ensure that the method handles all possible cases correctly. Asterisk use mocking, optional if a class depends on external services, example a database, use mocking to isolate the class being tested. 7. Pitfalls to avoid. Asterisk over abstraction asterisk don't over-engineer your code by creating abstractions that are not needed. Start with simple solutions and add abstractions only when necessary. You ain't gonna need it, yagna, is a good principle. Asterisk leaky abstractions asterisk an abstraction that exposes its underlying implementation details. This defeats the purpose of abstraction and makes code harder to maintain. Make sure your abstractions are truly hiding complexity. Asterisk premature optimization asterisk don't try to optimize your code before you have a working solution. Focus on making your code clear and maintainable first. Optimize later if necessary. Asterisk ignoring the solid principles asterisk violating the solid principles can lead to code that is brittle, hard to maintain, and difficult to reuse. Asterisk not testing asterisk failing to write tests can lead to bugs that are difficult to find and fix. Tests provide confidence that your code is working correctly. 8. Practice and iteration. Abstraction is a skill that takes time and practice to develop. The best way to learn is to work on real-world projects and to refactor existing code. Don't be afraid to experiment with different abstraction techniques and to learn from your mistakes. Iterative refactoring asterisk. 1. Identify complex code asterisk look for code smells in your existing code. 2. Choose a refactoring target asterisk select a small, manageable piece of code to refactor. 3. Write tests asterisk write unit tests to ensure that your changes don't break existing functionality. 4. Refactor asterisk apply abstraction techniques to simplify the code. 5. Run tests asterisk run your unit tests to verify that your changes are working correctly. 6. Repeat asterisk continue refactoring and testing until the code is clear, maintainable, and reusable. In conclusion, the key to mastering abstraction is to understand the underlying principles, like solid, to practice different techniques, and to write tests to ensure that your code is working correctly. It's an iterative process, and it takes time to develop the skills needed to create well-designed and maintainable code. Hopefully, this detailed guide has provided a solid foundation for your journey. Remember that the title "You Suck at Programming" is designed to be provocative. Take the spirit of self-improvement to heart, and you'll be well on your way to becoming a better programmer.